Welcome, everybody. Today we're working on Unit 11, and this will be kind of the introductory part of this unit. So we're going to go mostly through um, the activities and the reference materials. As I was just mentioning, this leans pretty heavily on our old Python book, which is, by the way, being phased out now. So next time we probably do this, we'll have to rewrite this unit. But because some of you still have access to that book, if you were wise enough to keep it, listen to your instructor, great. If not, I did like dumps of some of the information in here so that you have access to it. The one thing I will tell you is that the entire textbook's sample code is in the zip file here. So in other words, whenever we talk about like toolbox 1 or worked example 5 or whatever the numbers are, um, anything that was an example inside one of the chapter readings, the code for those exercises and the data files are in that zip file, outlined by chapter, and then broken down by specific item. And I think, just for example here, so if you unzip that file, you get all the chapters. Chapter 7 is one of the ones we're going to be focusing on, and we'll be working on, for example, toolbox 4. And then when you go in here, and let's say you're looking at the basic example, it has text files with data, and then it has a Python file with the solution. So we can bring those up, look at them, and utilize them as we see fit. And they also serve as a really good example, hint, hint, for doing the homework, right? Because sometimes the homework is just a tweak of some of these activities. But I just want to show you what's in that zip file. So we will be digging in here. I have the book up on the screen, and I'll be going through the material as indicated in the course show here. And the first one that we're going to hit upon is Toolbox 7.4. The files for Toolbox 7.4 are right here in the zip. So if you don't get the big zip and you just want a little zip, there you go. You don't have to pull down the whole thing. You have both accessible to you. And it says here, work through the examples in Toolbox 7.4, yada, yada, yada. And notice the red text there. This will help you prepare to complete some of the exercises below. All right, so this is probably the more important one out of all of them in terms of homework, at least. They make the point here that Python is very commonly used for doing data analysis, very much so. And now that you guys are kind of getting well versed in AI as well, you realize that all of AI is driven with data as well, right? So that's why Python is one of those languages that's used. People dig it for whatever reason. Not that you couldn't do this work with other languages, but Python is a little bit easier to learn, and data scientists really do prefer it, real frankly. There are different categories, by the way, of tools that are available for you to use inside of Python. Some of them do come from the standard library. So for example, and I think they make mention of it here too somewhere. The standard library function has functions for computing the mean, median, and standard deviation. And if you guys are studying stats right now, that terminology should be somewhat familiar. The mean, of course, is where you add up a bunch of stuff, divide by the number that you have, and then it gives you your average. Mean is typically what we call average. The median is sort of an average, but it's not a mathematical average. It's an indicator of which value happens the most. The middlemost value is the median. Of course, there's the mode, which is just a straight up count, but that one's not included here. And then they have the standard deviation, which means if you have a mean, how far away from the mean can you expect most of the values to fall? That's kind of a very quick way to think about standard deviation. Those are very common measurements when we look at statistics. And when people present statistics to you, those are very common ones they put, in your face, basically, polite way to say it. Like if they say, oh, hey, we took a poll of the presidential candidates and, it's 49% for one and 52% for the other, plus or minus 3%, right? So they're giving you a mean, right, and a standard deviation. With the standard deviation basically showing you the error amount, of what that is. One of the things that they're giving here is an example. It says, for example, when data contains the populations of the world's countries, right, and we do a straight up mean or average on the population of those countries, the mean is about 30 million, where the median, which is really the middlemost number, is really more like 4.6 million. So most countries on the planet have about 4.6 million people. That's about the size of Wisconsin. It's not really that much, right? But you get a country like India or China that have 1 point something billion, and like half the world's population is in those two countries. Of course, it skews the numbers, and it's not half, but it's a very large uh, percentage. And they make the point here that the standard deviation of 122 million is not very useful, right? When most countries have about that population. So sometimes those measures are useful, sometimes they're not. And whenever you do like what we call a distribution of means, usually you get like these shapes like the bell curve, right? And that's how the standard deviation was originally sort of developed. And these are terms that you learn about in mathematics, right? And I'm not here to teach you math, but I can talk about it. And I will tell you that understanding math and statistics is really pretty important for working in IT. It's especially important for AI and data work, right? So that's why we ask you guys take a statistics class. All right, so they have some sample code, and here's an example, right? And we can actually run this code, by the way, but you'll notice that they have, they're importing the statistics library, they're importing the matplot library. It's kind of interesting how they do the import on this one. You guys notice that? A different form. This is more like a Java style import where they have a dot notation in there. And what they're doing here is they're writing a function called show stats, creating an empty list, reading in some files, appending them to a list, and then running a mean on that data, a median on that data, and a standard deviation. And then they're doing an output that's a formatted one. And then they show a bar chart and they put it up on the screen and they read in two files. Now this, I don't know if this might not execute on my screen. However, we have the files, and this is why I provided them. So you could do this, what I'm about to do. So you could go here, download that zip file, and you can see I have it multiple times over. And you know what? I'm going to extract all of it so that it'll just be there. There it is. And then for the basic one, they have that Python program here. And in principle, I can just run it and it'll, I can double click it and it will run. But I do want to open it up inside of Spider. So I'm going to go to Spider. I'm going to go here and open up that particular file. And that's in my downloads folder. And of course, nowhere handy, but I did find it. And I'm going to open up that program because I want to look at the code before I run it. It's basically what we're seeing in the example, right? So there's the code. The world population and the other thing there, I'm not sure what file that is, are just text files that happen to be inside here. It's not a bad idea to look at them. So this is the world population. So it looks like a tab separated list of countries and their populations, right? That's the first file. The second file is, okay, I see. Oh, these are the heights of the presidents. Like that has like some sort of a bearing. So this must be for a different example. Yeah, so you can see how tall. So let's see which president was the tallest. Apparently George Washington was pretty darn tall. He's 189 inches. It's interesting to know. I'm not sure why that's useful, but it's interesting to know. All right, so this first program then is going to first process the mean, median, and standard deviation of the world population and create a chart. And then it's going to process the president's heights. And what I'm going to do is I want to run these discreetly. So I'm going to comment out the presidential heights first. I'm just going to run it with just the world population. Okay. So here goes. I'm going to hit the run button. And there's the breakdown. So this is the breakdown of that. And I'm looking here also in the console because it has output for me, right? So the mean is, what does that come out to? And this is what we said before. It comes out to 30 million is the mean, about 4.6 for the median, and the standard deviation is really high, making it pretty useless. And then what are these data points that we're looking at? Well, it's not really described, right? Because we didn't set up ticks down here to say like, oh, well, 0 is whatever. But can we guess that the really tall one is China? Probably. The second tallest one is probably India. Yeah, well, that's probably what it is, right? And then, of course, we're around 300 some million, so this might be the United States. And if you think about it, if this is China, that's C, this is I for India, and the United States is right there. So what country falls right here that's a little bit, bigger than the United States in population? The letter, it starts with a letter after C and a letter before I. Well, you know what? We could look at the data and figure it out. But this chart is actually an example of like, it doesn't really show that nicely what the data is. It's plotting it, but this is why it's important to label stuff or have a legend, because how do you know? You just don't, right? And maybe this little bar chart, I mean, trying to put like 175 bars on the chart is kind of hard to begin with also, right? So maybe not a great idea. Let's now flip this off, the first one, and run the second one. So I'll just run that one. So this is the heights of the presidents. So you can see most presidents are, about the same height. There's a little variance. Maybe this isn't a really good way to present it. But once again, we are able to read in a file, visualize it, and run statistics on it right here. We could also write additional code where we could figure out, what is 180 inches, I assume, right? How tall is that? We'll divide by 12, right? And you come up with, right? Everybody's like really fast on their math here. Yeah, not at all, right? But that's okay. All right, so this is the example from that toolbox. Right, I'm going to go back here and I'm going to keep reading down the chart. Now, there's a bunch of other types of statistical measures, and these are things, and I'm not once again here to teach you stats, but I just want you to be aware of these things. And in your stats class, you'll learn about this type of stuff. But this is the chi-square test, and I think how do they describe it here? It says the common use is to test whether there's a significant difference between two variables. For example, we may want to find out whether test scores vary between male and female students and whether they are influenced by family income, or one distinguishes between categorical and continuous variables, et cetera, et cetera, et cetera. And, so there's a measure that you can take to see how much difference there is between different data types, for example. Okay. So there are tools built in that do that. So that's kind of the point. The stats libraries have a lot of this stuff, like the standard stuff that you do is all built in. We can also look at things like the ANOVA, right? So this is another thing that you learn in your class when you take statistics. And you can use this to kind of drill down and get into some other stuff. They have sample code here and everything. Another real big one is linear regression. And this one I like to focus on a little bit more because that's a really common thing to do. Is basically you usually have a linear equation So, okay, so what does that mean? When you do an algebra formula, if your formula does not have exponents or square roots, or powers basically, um, then the equation that it forms when you plot it on a chart tends to be a line or close to being a line on a chart. And we're comparing usually two dimensions of variables. So for example, here they might compare, for example, the country, per capita income, life expectancy. I'm not tertiary education, meaning like I guess maybe master's degree or college degree or something like that. Health expenditures, per capita, GDP, and whatever the Gini number means. And you can take a look at, basically, when you do a regression, you can compare two values. So for example, we can compare life expectancy to income, that kind of like weird stuff, right? And then you can plot that and see what it looks like. And yes, the files to do this, if you want to try this, once again, are in that zip. So if you want to look at the ANOVA example or the regression example, all of that stuff is here, right? And so they have the programs that do it, and then you can run the programs. And this one does a scatter plot. It shows a line of where the equation is assumed to be. You can see that the data is not necessarily a good fit with that line. It is at times, but at times it's not. And then it shows the correlation coefficient, which is pretty low, meaning that whatever data they were looking at here is life expectancy and health X, whatever that means, are not highly correlated, is what that means. If this number was a really high number, let's say it was like 0.8 or something like that, the line or the dots on the chart would be a lot closer to the line all the way across, right? And then you say the data is highly correlated and the correlation coefficient is high. Here, it's showing us that it's only about 1/3 of it is really correlated. It does plot an equation. There is a regression equation, but it certainly doesn't work well for this data point or that one. It kind of works okay for these up here. Maybe even I would include these, but generally speaking, it's a loose fit. So these are the kind of weird statistical things that we look at. There isn't necessarily a correlation is kind of the point. All right, let's move on. So I'm going to move on to the next topic here. So that would be covering using Python for statistical analysis. Another thing that we can do is we can look at worked example 6.1 here. So I'm going to go to chapter 6, and then I'll go to worked example 6.1. And in this situation, they start plotting trig functions. And this, okay, now what's so interesting about plotting trig functions? Trig functions, like when you guys learn how to do like geometry and trigonometry, right? That's where you bring in the Pythagorean theorem. So like, how do you figure out like this, one side of a triangle and how much area, and, and that kind of weird stuff. And then ultimately what happens when you're working with those kind of equations is you do end up squaring things and doing square roots, which leads to all the trigonometric functions, including sine and cosine and tangent and all those kind of weird things. And when you start plotting trig functions on a two-dimensional graph, instead of them forming straight lines like the regression equation that we just saw, they start forming curved shapes of various sorts. So, the example that they have here, right, sine and cosine, right, and these are like, I don't know why I remember this stuff, but like when I took calculus one too many times, in my academic career, I know that the sine of 0 is 0. Is that one of those things I had to memorize, and like where it crosses like certain points on the graph. And these are continuous waveforms, and those waveforms can be altered. So cosine alters one way, sine alters the other way. And because they are not linear equations, they don't plot as a straight line on the graph. So these are non-linear formations, right? Or trig functions. So they have all these, all this like trig formulas, geometry formulas, calculus formulas that they have built in as well. And then they show you here how you can plot these things, and they give you examples of how to plot them. And yes, it is sometimes useful to plot those things, and they give example after example of the stuff. So this is how you would do it. I'm not going to demonstrate this one, but I just want to show you this, that there are certain types of equations that plot in nonlinear formation, and Python does have libraries for doing that kind of work as well. And I think that's pretty fascinating. All right, the other one I did want to focus on a little bit, and I think this is kind of fun. So this is from Toolbox 8.1. And so we're going to go to that in the book here. And we'll just scroll right to it. And I do want to talk about a couple different concepts here. The first thing I'll tell you is I think the links they provide are probably dead at this point or changed. So like if you try to follow these links, they might not work. The unfortunate thing is whenever people print a textbook, by the time they actually print it and put it on a shelf and get it in students' hands and people are reading it, years go by sometimes, so it's also one of the reasons why we've decided to kind of move away from textbooks, is sometimes they become dated very, very quickly. One very common use for Python, and I know a lot of professional programs that use some of these tools, by the way, to extract information from websites, because a lot of information gets published on websites, but you don't necessarily have access to the raw data files that created the data that's going on a website. Whatever their process is, they take maybe it's a CSV file, maybe it's an Excel file, like who knows, right? How the data is formatted, but they read it into their website somehow, probably with a backend programming language, could even be Python, but more likely it's like C# or JavaScript or something. And then they turn that into something that you see on the screen, whether it's a visualization or if they're just showing you the data numerically, whatever the case may be. And then if you want that data for your own purposes, if you don't have access to the data file, right, they don't provide it, then your only choice becomes to extract the data from the website directly. That process typically is called scraping, by the way, right? And this is an activity that programmers do, and a lot of like web geeks do this kind of stuff. Some important terminology here. The first is what we call an application programming interface, or API. And this is a term that programmers throw around very loosely, but basically all an API is a computer program or a library of computer programs or functions or methods. They can be in any language, by the way. All languages have them. Python does too. But basically, if you have a library of functions that you're pulling from and you know how to utilize those functions, you're basically interfacing with a program that's pre-written. You just need to know the syntax for how to use it. So for an example, when we were writing, these, so we're using a few different libraries here that you can see. Anytime we're using matplotlib, right, and we're not aliasing it, we call it in, this is basically an API call. So we're pulling in that library, this particular program, and this particular function or method from that program. And then we're feeding in the parameters that it's asking for, and it just does some magic and puts it on the screen for us, right? And that's an approach we call an API, right? So really, when we're using a library in a programming language, that's an API, right? I didn't have to write the code that created this graphic. I just utilized the tool that did the work for me. This is an application in and of itself. The terminology I use to access features of that program, that's called the API, right? So that's pretty common. Another thing that's kind of interesting here is this thing called JavaScript object notation. And I'm just using the AI return here, but this is a way that we structure data for most programs these days. It is a very, very popular tool. It's been around actually for quite a while, but if you look at even the examples of the code here, and I don't know how well you guys can see this, but I'll zoom in. Okay, I zoom in and it makes it smaller. It makes a lot of sense, right? All right, we'll leave it like that on the screen, but I want you to notice the format of the information here. A JSON data object is similar to what we call a dictionary in Python. If you guys remember the difference between, let's say, like a dictionary or a set or a list or a tuple, right? Those are all data structures. A dictionary is where we have one named structure that can store multiple values, but there's no index value for the thing you're storing. You store it with a key value pair, right? So these are key value pairs. So for example, this is employee ID, that's text. Then there's a colon, and then the data, so the guy's employee ID or gal's is 1. The next piece of information separated by a comma is last name. That's the key. The value is Davis, comma, first name Sarah, title CEO, so you see the pattern. So that these are keys on the left, values on the right, key value pairs. That is how JSON works. And if you notice here, and I know this is very hard to see, but JSON uses curly brackets to hold it all. Same thing we use in Python for dictionaries, by the way. And you can form data objects this way. So this is called JavaScript object notation. So why is this so popular? Because JSON mimics the key value pair structure for every major programming language. Python, Java, C#, C++. I could go on and on, right? So a lot of languages use this as a data transmission format. So it's become very, very popular, by the way. If you're curious about doing this, right? So they have some examples here. I'm not going to click through on any of the links or anything, but you can set up a URL in your program, and notice they're just taking the URL and putting it in a thing called the address. They're setting up some structures here, and then they're just pulling in an API that they're reading through and decoding the information on the page, and they're getting kind of specific, right? They're not looking for all the information, but they're structuring a URL based upon what we call a get statement. Now, this really does go down a rabbit hole, but I'm going to show you what they mean by this. If I go to Google and I search for, I don't know, whatever I search for, let's say weather Milwaukee, right? And this is really a Google search at this point, right? And let's just emphasize that by typing here. Let's just say weather spelled correctly, Milwaukee. Okay, and then I'm going to search. Oh, and of course I hit the microphone. Weather Milwaukee. All right. Sorry, Google. Sorry for messing you up, Google. Didn't mean to. Let's just do it like that. But here's where I want to pay your attention to. I know this can be hard to see on the screen, but notice what Google does is they take you back to their website. They put you in their search mechanism. So this is like the base URL, google.com/search. Then they put in a question mark, and then a Q, which stands for query, sounds like database class, right? And then an equal sign. Then you notice they have double quotes, and here's my search terms, weather plus Milwaukee, and then a bunch of other weird gobbledygook. But basically, this part of the URL captured my search, and it's visible in the address bar. This is called a get in the web world. So in other words, this is the information we're getting or querying, and it's visible in the URL as we're running the query. And so when you look at this snippet, notice this would be google.com/search, the question mark, the Q for the query and the equal sign, and what you're searching for. Isn't that interesting? Right. So what they're telling you here is you can propagate a even a search URL inside of a Python program, and then it'll go to that URL. So that's what this does. The URL library requests a URL. It opens up what URL? Well, the one you just specified, which happens to be a search, and it'll pull all the data that's related to that and store it in a variable. Super powerful, by the way. Right. Then that's a big chunk of data. So whatever's on that web page, and by the way, whenever you go to a web page and you pull it up on screen, and I'm going to use something simple here, maybe like this. If you right click on a blank area of a web page and then hit view page source, you can look at the code that creates that web page. This is the code that creates that web page. Right. And if you were one of my web students, this is the stuff you learn, by the way, right? So what's really happening then is when we run these commands, it's going to the web page, it's doing that right click, and it's reading all the code in and storing it in a file. And now you guys know, like, this is just a text file. Once we have the text file captured, now Python can traverse it very easily, right? And it has a bunch of tools built in that allow you to decode it. So what it does is it starts breaking down the information, and I want you to look at what it's doing. Key value pairs, key values, right? With the values being another key value pair, right? It gets kind of deep, but this is how the data is transmitted. So it can actually go in there, find the data it needs, basically filters through it, returns the data that you want in the format of key value pairs, and now I can pull that into my Python program and do stuff with it, whatever that happens to be, right? Could be process it with AI. It could be converting it into a visualization or making a chart or whatever the task is. If you have the data, then you can build the application from it. And they make the point here, JSON uses the same notation for lists and dictionaries as Python. Yeah, totally. Right. And that's another reason why it's so popular. You can take that information, you can read through the key value pairs, extract very specific pieces, by the way, and then feed your application. And the beautiful thing is, right, if you ever go to the National Weather Service website, and you know, I always tell people, it's like, why do you go to like weather.com? You should go to NOAA, because that's where they get all their data from. You know, why go to the secondary source? Go to the original source. And plus, there's no ads on this page where all the other weather sites have ads, right? It might not look as nice, but this has data. And what's fascinating is that for any forecast location that you go into, and I'm not sure if I'll find this really quickly, but oh, here you go, right? You can pull in, you know, data directly, and they have these two formats, but and I'm just going to like click into one of them, right? And this is the KML data for, I'm just going to open it up with Notepad for right now, not always, just once. But remember, we were looking at the XML file a little bit. Oh, no, you guys don't remember that because we haven't done it yet. But in the AI class, we'll be looking at an XML file. All right. But XML is just a format, another format for data. It's not JSON, but it's similar. But you can actually pull in the data in raw format from the National Weather Service website. And that wasn't a very good example. But if you wanted the all the data points, and maybe this is a better example. I don't know, somewhere in here you can get all the live data feeds, but they create all these charts and graphs and maps and radars and forecasts, all with data, and that data is publicly available. So you can read the same data, you can make your own weather app if you wish, right? You know, so just a matter of knowing where to find it. And Laura, I see you have your hand up.
I just had a question about the page source that you just showed with the code on the back end. Is
Yeah.
that the same as the inspect? Because I click on the inspect and I didn't know if it was the same exact code like the HTML and CSS.
I'm going to say partially it is. And just let you know, Laura, I don't know if it's your feed or mine, but you sound like a robot. You guys hearing that a little bit? Anybody? No, maybe it's me. Yeah, you sound like Max Headroom or something like that, if you know who that is. No, there is a difference. And so if you, and you always, whenever you do this on a web page, you always want to do it where there's no content, like a blank part of the screen. Because if you do it on top of like a graphic or an object, it doesn't give you that, right? But if you right click in a blank area, page source is just the raw text file that gives you, that makes the page, right? If I'm on the page and I right click and I hit inspect, that's a different type of tool. Yeah, you can still see the code, but it's broken down by object and it's got a bunch of other tools built into it that are really designed for professional web developers and designers and programmers and whatever. And that's not what we're doing here. Um, the, um, the fascinating thing about the data aspect, right? So this is a very primitive example once again, but it is possible to do that. There's a bunch of different libraries that are built into Python for processing URLs and web pages, right? So the request tool reads the website, the parse tool reads through the code of the website, the JSON tool turns it into JSON objects. And then once you have it in that format, well, then, gosh, you can do just about anything with that data. That's really the point of it. Sometimes people are hampered in retrieving data, like I said, like with the COVID data. If they weren't putting it on GitHub, how would the world get those numbers? How would the news agencies report on that stuff? You know, do you expect like the one organization that's doing it to disseminate it? But no worries, I'll email it to you. You know, no, that's not happening. They put it in a central repository like GitHub where everybody can access it in real time, just the way they do. And that makes a whole lot more sense. They do show examples on how to use this. And this, once again, is a very primitive example. But people do use this, what we call scraping technique, to extract data from websites and then use that data for other purposes, right? Normally, when they don't provide a straight up data feed. The one thing that I will kind of point out is like when we were doing like the COVID-19 stuff, and we were looking at some of these dashboards, for example, and I don't know if this will work right now, but we'll see. And like this is like a visualization library, right? And notice that Tableau, which created all of these visualizations, you do have access to download whatever thing. Okay, so this would come down as an image, but in some cases you have the ability to grab the data also that's building it. And I'm not sure. And maybe here. Yeah, I'm not hitting it very elegantly right now, but a lot of time, a better visualization, like if people have like, oh, I created this chart, or you really want to see this chart, well, here's the data that I created it with, so you can grab it and you can do whatever you want with it, so you don't have to believe me, right? But you know, that data is built upon a data file, a very specific one. And some people are forwarded with their data, and other people you have to kind of dig in and find it. Some people don't share it at all. They just give you the graphic and that's it, right? Maybe that's not what you want. Maybe you want the raw data file, right? And it is the raw data files that have the information, the true information in them. And that's part of it, right? Because I don't know if you guys are picking up on the fact, but I could take a data file and I can exclude certain information when I'm putting a graphic together and make it look a certain way when it's not appropriate. That's why having access to raw data files is important, you know, and that's maybe the grander takeaway from all of this. All right. They do have an example of the weather thing, and I don't know if that one will run or not, but I did have that here somewhere. So that's, I think, chapter 8. And that was toolbox 8.1. And I can try to run that. Let's see if it even runs. Right. And this is assuming this API link is still active. And it might not be. Okay, so enter the location, and I'm not sure what it's looking for as a location. I don't know. Maybe we can just type in Milwaukee, Wisconsin. Not what it's looking for. Maybe it's looking for a zip code. Somebody want to read up on it and tell me what they're looking for? Yeah, and right now, you see what it's doing? It says unauthorized. So I think the link is basically broken. But when this was working, you could pull in a forecast and a temperature and the wind speed and all that dynamically just from the command prompt. Martin?
Hey, really quickly, I wanted to ask about the final project. There's a mentioning there of a data dictionary that I'm not sure I'm finding. It says you will also want to review the attached data dictionary. But I don't see an attachment other than the CSV and the Word document itself.
Yeah, the CSV file contains the data dictionary.
Oh, okay. All right. Thank you.
Question. All right. So at this point, what I do want to do, and I can answer questions about the final project. And I just want to let you guys know, I don't know how my signal's traveling across the internet right now, but anytime one of you guys talk, the audio and the video is choppy, so when we get done with this class, like now, I'm probably going to reboot my machine. What I do want to talk about is these 2 assignments. So this information is partially provided, right? So in other words, they want you to modify 2 programs and then submit those. So next time when we get together, we will go through that process. The other thing I will say is that I'm going to end this recording here. And then